Hello, my name is Steve Bowler, and welcome to Introduction to Juniper Lab number 2. In this lab, we're going to be taking a look at the basic configuration of physical and loopback interfaces. We are going to be using the Juniper SRX 210 network device, just like we did in the Introduction to Juniper Lab number 1. And as we can see from our diagram, the laptop that I am on and talking to you from, the laptop is connected to the gig 000 interface on the SRX 210 device. And I'm going to be using PuTTY to telnet, or I'm sorry, we're going to be using PuTTY to SSH to the IP address into the box, which is 192.168.1.1. So in this lab, we're going to go over adminning up or bringing up an interface. We're also going to show you how to deactivate and disable an interface. In particular, the interface we're going to use for that is going to be gig 001. We're going to go over some of those features when we deactivate and disable. We're going to talk about the difference between them. We're also going to show you how to add a description to an interface. We're also going to add IPv4 and IPv6 addresses to interface. And we're going to show you and explain to you the concept of a unit and a family when it comes to the Junos configuration. For verification, we're going to perform show commands such as show interface description, show interface terse, and show interface followed by the interface name. And we're also going to show you how to use the rename function and how to quickly use that to rename an IP address. And the last thing we're going to do is we're going to be configuring a loopback interface on the Juniper router. For obvious reasons, we do that for our routing protocols that we use, and for other purposes. We don't want routing updates to be sourced from our physical interfaces, obviously, because if one of those physical interfaces goes down, then our routing protocol might have to update, and it might take down the routing protocol altogether. So we don't want to do that. So what we do is we configure a loopback interface, which is an interface that will never go down. Because once we configure the loopback interface, it's always in the up state. So the first thing we're going to do is we're going to get into our router. We're already in the router, and its name right now is Juniper Lab. Let's go ahead and take a look at interface gig 001. That's the interface that we're going to use in this lab for the majority of the lab. And the first thing that we can see when we do a show interfaces gig 001 is that we're seeing that the physical interface is, this is Ethernet, this is the link level type. We're seeing that the interface is enabled and that the physical link is down. So the interface has been admined up. By default, it's admined up. However, there's nothing on the other end of this link. As we can see, we don't have another device on the other side of gig E001 in the network diagram. So the physical link is going to be down, which it shows us. So one of the first things I want to do is show you how to disable an interface. So we're going to go into configuration mode, and we're going to do the command set interfaces followed by gig E001 and then disable. So I'm going to go ahead and hit enter. I'm going to commit and quit. Then we're going to do another show interface. We're going to see exactly what happened when I did this command. So now if I do a show interfaces gigi001, we can see that the interface is now administratively down. So in essence, we have admin down the interface. And then again, the command to do that was set interfaces gigi001 disable. And what did that do? That admin down the interface. So the way we're going to bring this up, and it's kind of tricky if you're new to Juniper, the way we're going to do this is by using a double negative. So we're not going to do the command set interfaces gigi001 enable. As we can see, as we try to put in en and then hit tab, we can see that encapsulation is the only option we have. So we can't do a set interfaces gigi001 enable. To admin up the interface, if it's in the administratively down state, as we can see above, the way to admin up the interface is actually, if I do a question mark, we're going to use the delete statement, or the delete option. So we're going to do delete interfaces gigi001 disable. And let me just show you, if I do a show interfaces gigi001, we can see that, let's go ahead and do this. Delete interfaces gigi001 description. Sorry about that. I left that out. I'm sorry, I left that in from when I was practicing this lab earlier. So you weren't supposed to see that, but it's no big deal. I'll show you how to, again, that was just one of the options that I was going to show you how to add the description to an interface. Let's go ahead and do the command show interfaces gigi001. We can see that the only statement we have under the gig001 interface is disable. So to change this option, we do the command delete interfaces gigi001, and then we follow it up with disable. So now if I do a show interfaces gigi001, you can see that the disable is gone. So let's commit and quit, and then let's go back and see. We'll do a show command. We'll do a show interfaces gigi001 to see what has happened. So if I do a show interfaces gig001, we can now see that the interface is enabled, but the physical link is still down, and that is because there is no router on the other end of this link. But that's okay. For the purpose of this lab, we're not worried about a point-to-point connection being made. That's going to be in the next lab. That's going to be in our introduction to Juniper lab number 3. We're going to go over how to set up a point-to-point link. In this lab, we're just going to teach you the basics of the physical and loopback interfaces, because you need a solid understanding of how the interfaces work before you can even worry about trying to set up a point-to-point connection. So that's how you would properly admin down an interface and also admin up an interface. There's a double negative that you use. You're deleting a disable statement. So the double negative actually equals a positive in this case. So the next thing I want to do before I show you the use of the deactivate command, I want to show you how to add an IP address on an interface. So when I do this, I'm going to also explain the concept of the unit and family options. So say right now when we do a show interfaces GigE001, all we can see is that there's the physical interface. We're not seeing any other type of interface associated with GigE001 when we look at it. What we're going to do is we're going to add an IP address on the physical interface. I'm sorry, not on the physical interface. We're going to add an IP address to GigE001. And the way we're going to do this is we're going to go under Edit Interfaces, GigE001. And now we're under Edit the interface configuration mode for GigE001. We're going to give the IP address of, well, let me just show you. If I do a set and then question mark, you see that we have an option for a unit. And the Junos quickly tells us that a unit is a logical interface. So right now, again, if you look at the show interfaces on the GigE001 interface, we see that we only have a physical interface associated with no logical interface. And that's because we actually have to go in and define our logical interfaces. The way we do that is do set unit space question mark, and then it's going to ask us for a logical unit number. In this case, it has to be a 0 because we can only have one logical interface supported on this GigE00 or for this gig interface. So I'm going to do the command set unit 0. Again, that's going to tell us that's logical unit 0. And if I hit a question mark, you can see that I have multiple options under here. So what we're going to use to assign an IP address to GigE001, we're going to have to define first our logical interface, which is logical interface 0. We're also going to have to tie in and use what's known as the family option. We can see that we have a definition of the protocol family, but what does that mean? So if I hit family space and then question mark, we can see that we have multiple protocols that we can define with the family option. We have INET, which is IPv4 parameters, INET6, which is IPv6 parameters. We have ISO, which is ISO parameters, and we have MPLS, VPLS. So you can think of defining the family is defining, okay, what protocol what kind of IP address am I enabling MPLS on the interface? That's exactly what the family option is telling us. What kind of, in this case, we're going to be using INET to define our IPv4 address. So we're going to do set unit 0 family INET space question mark. We can see that we have further options. So we can do filters, we can do policers, we can create an unnumbered address, we can assign DHCP. In this case, we're going to use the first option, which is address. So we're going to do set unit 0 family INET address, and then we'll just give the address for GigE001. We'll give it the address of 172.16.1.1. And you can see the way that we're going to assign the IP address on the Juniper, within the Junos, I should say, is we put the subnet mask as the, in this case we'll use the /24. So it's just that simple. I don't have to write it out in dotted decimal format. I don't have to do that to represent a /24 subnet mask. I can just write the subnet mask in as the /24. So I go ahead and hit enter, and then we can do the command like I showed you in the introduction to Juniper Lab number 1. We can do the commit check statement to see if this will actually, if the router will actually let us to apply this configuration, and we're getting the statement configuration check succeeds. So we should be able to commit and then check the interface and see if what all has changed. So now that the commit has been complete, let's go ahead and do a show interfaces gigi001. And now we can see, in addition to the physical interface that we saw before, we are now seeing a logical interface tied in as well. So let's go ahead and take a minute to talk about the logical interface that we just set up. We see that we have no input and output packets. Obviously, because the physical link is down, we don't have a point-to-point connection. We can see that the protocol is INET, and that is exactly what we defined with the family option. INET meaning IPv4. We can see that the addresses, the destination, this is going to be our network that we're on. This is the 172.16.1.0/24. It also gives us the local IP address on the network, which is the IP address of the interface, the logical unit, which is 1.1, and it's given us our broadcast address. We all know that 1.255 is the broadcast. So some really good information that we can get out of this show command. We're now seeing the logical interface that we just created. See if we can ping this. And we can't ping that right now. It's no big deal. So let's go ahead and let's jump to our next subject. Let's go ahead and show you, let's go back and do the edit interfaces gigi001. And now that we have our IPv4 address, let's go ahead and put in an IPv6 address as well. So we'll do set, again, the unit. It has to be unit 0. And now our family is going to be different. For the IPv6 address that we want to put on, we're going to use the family INET6. So we'll do set unit 0 family INET6 address. Then we'll just put an IPv6 address. We'll just put 2001:1:1:1:1/64. So this is a IP address. This is a IPv6 address, a valid IPv6 address, I should say. So we'll go ahead and put the IPv6 address on, and we'll do a commit and quit. And then we'll look at the interface again. We'll do a show on the interface. If I do a show interfaces gigi001, we can now see that we have a second protocol under the logical interface gigi001.0. We have the protocol INET6, and this is IPv6. So for the destination, we can see that this is the network address, and then we can see the local IP address, IPv6 address, I should say, that we assigned to the logical interface. We can also see some of the link local IPv6 address information as well. So let's now go ahead and take a look at, before we showed you how to admin down an interface and also admin up an interface, let's go ahead and show you how to deactivate an interface. So say we want to deactivate gig001. Let's go under configuration mode. The way we're going to do this is simply with the deactivate option from the top of the edit mode, or I'm sorry, from the top of the configuration mode hierarchy. So I do a deactivate interfaces gigi001. Let's do a commit check to make sure that works. go ahead and commit that. And before I exit, just want to show you how this deactivation of an interface looks in the configuration. So if I do a show, and under the interfaces on the SRX210 on the router, we can see that next to GigE 001 we have the word inactive. So let's go ahead, now that we see that under configuration mode, let's get out of configuration mode, and if I do a show interfaces GigE 001, we can now see that the logical information that we had on the interface is now gone. I want to also introduce you to the command show interfaces terse. And what the show interfaces terse command looks like is, you're probably wondering, well, this looks pretty familiar. This is similar to, on a Cisco iOS device, doing the show IP interface brief command. So it outputs to the left our interfaces on the local device, the administrative state, the link state. So again, for GigE 001, it is enabled. However, the link is down, and we do not see the logical interface in this output. However, we do see the logical interface on GigE 000, and this is the interface that we're connected into the Juniper system through our laptop. So why doesn't the logical unit show up for GigE 001? The reason for that is because we deactivated the logical interface. So a deactivation command will take off the logical portion of the interface. Let's go back to configuration mode, and if we take a look at how to activate the interface, you might say, well, it's probably just a delete, right? Delete interfaces GigE 001. Deactivate, but there is no deactivate statement. So the way we actually activate the interface is with the command, if we do a question mark, we can see that it's the very first option. This is telling us that this is going to remove the inactive tag from a statement. So if I do activate interfaces GigE 001, let's go ahead and commit and quit, and we'll do a couple show commands and see exactly what has changed. If I go ahead and do a show interfaces terse, now we can see that we have the logical unit 0, GigE 001.0 showing up. We have the protocol iNet and also iNet 6. So we have the IPv4 address that we set, and we also have the IPv6 address. Also, if I do a show interfaces GigE 001, we can also see that the logical interface has returned to the configuration. So to wrap that up, the deactivate statement will take off the logical interfaces that are associated with the interface. In this case, we had GigE 001 that we deactivated, and it took off our logical interface, which was GigE001.0. So let's go ahead and move on to our next thing that we want to learn in this lab, and that is going to be how to set a description, an interface description. So the first thing we'll do is we'll go under Edit Interfaces GigE001. We're going to use the Set option. We can see that if we do a set space question mark, we have the description option. This is going to allow us to set up the description of an interface. So let's just say GigE001 on this Juniper device goes to router 2, and we want to annotate that in our description of that interface so that whenever people look at the device, they know exactly where this interface is going. So we do the statement, we'll do the command set description. Then we'll just add our description. We can name it, if we do a space question mark, it just says text description of interface. We'll just put connection to router 2. We'll commit and quit. Also, I just wanted to show you, let's go into configuration mode. If I do a show interfaces GigE001 real fast, wanted to show you that it no longer shows, if I do a show, let's just do this, show interfaces, it no longer shows the inactive tag next to GigE001. Also, it's showing up our description as connection to router 2. So let's go ahead and see where this shows up. If I do a show interfaces GigE001, we can see under the physical interface it tells us that this is the description, or this gives the description, I should say, as connection to R2. Also, I can do the command show interfaces description, and we can see that this is going to give us all of the interfaces that have a description assigned to them. In this case, it only is going to bring back GigE001 because that is the only interface on our router that we have added a description to. So the next thing we want to do is, if we do a show interfaces terse, you see that we have a loopback 0 interface. And what we want to do with this loopback 0, we want to give an IP address to it. Obviously, like I was telling you before, it's best practice to use a loopback 0 interface, especially when you are running routing protocols and you don't want to have a physical interface on your router to be used as one of the neighbors, or one of the interfaces that's actually passing updates for your routing protocol. Because if that interface goes down, then your routing protocol might also as well. However, if you assign an IP address to your loopback 0 interface and use that as your interface that you are broadcasting your updates from and using for your routing protocol, well, then you will never have to worry about that interface going down, because the loopback 00 was always going to be in the up state. So it's best practice to use your loopback 00 interface in that manner. So we'll go under configuration mode and we'll go under edit interfaces. We'll do loopback 0. We're going to define, just like we did on the physical interfaces, the physical Ethernet interfaces, we're going to define a logical unit in this case unit 0, to it as well. Or we can just do edit interfaces loopback 0. So if I try to set unit 10 family inet address 1.1.1.1/24, if I try to do that and do a commit check, we can see that we get the statement configuration check succeeds. So if I do a show from loopback 0, we can see that we have a unit 10 with the family inet address of 1.1.1.1/24 on it. What's going to happen if I go and try to set, also let's try to set another logical unit. We'll do set unit 0 family inet address 10.10.10.10. We'll also do a commit check, and we're getting the error message now when we check to see if the commit will succeed. We're getting the message under unit 0, multiple loopback interfaces not permitted in master routing instance. So we can really only assign one logical unit or one logical interface for our loopback 0 interface as well. If I do a show, you can see that we have two defined. We have unit 0 and unit 10. So let's go ahead and delete unit 10, and we'll do a commit check now and see what happens. So now we can see that we're back to configuration check succeeds. One of the things you can do, though, is you can add multiple IP addresses on the loopback interface. So say we wanted to add the 1 network as well, along with the 10 network. If I do a show, we can see that we have the 10 network under unit 0. Well, let's go ahead and do this. Let's do a set unit 0 family inet 1.1.1.1/24. I'm sorry, forgot the address. inet address 1.1.1.1/24. Now we'll do a commit check and see what happens. We can see that the configuration check succeeds. So if I do a show statement, now we can see that we have multiple IP addresses assigned to the same logical unit. So if I do a commit and quit, let's go ahead and take a look at the show. Some of the show commands. Let's see what we get. So if I do a show interfaces terse, you can see under loopback 0.0 we have two IPv4 addresses. Also, if I do a show interfaces loopback 0, you can see them defined under loopback 0.0 as well. We see we have the 1 network and the 10 network. So that's one way you can do that. Assign multiple IP addresses to one logical interface. So now that we have an understanding of how to configure the loopback 0 interface, let's go back to our gig 001.0 interface, where we have the 172.16.1.1/24. Let's say that one of our network administrators accidentally assigned this subnet /24, and we need to go ahead and change this to a /30 because it's a point-to-point link, and we have other IP addresses on the local subnet that are being used. Let's change this, instead of a /24, we'll change it to a /30. One of the easy ways to do this is with the rename option. So if I do a question mark, you can see that the rename option is present. We can do a rename interfaces Gigi001 unit 0 family inet address 172.16.1.1/24. If I do a space question mark, you can see that we're going to be using the to option, which is to provide a new object name. So to summarize, what we're doing is we're going to rename, this is the before part of this command, we're renaming the interface Gigi001 logical unit 0 family inet address 172.16.1.1/24. We're going to rename that to 172.16.1.1. So the same IP address, but we're just going to supply a different subnet mask. We're going to change it from a /24 to a /30. I'm sorry, forgot the address option. So we're going to do to address 172.16.1.1/30. So I'm feeling kind of bold. I'm going to just go ahead and commit and quit and see if this works. And we can see that the commit has been completed successfully. So now if I do a show interfaces Gigi001 under the logical interface, we can see that the IP address, the subnet, has changed from a /24 to a /30. We can see that this is true because we're seeing the local IP of 1.1, and we're seeing the broadcast, instead of 1.255, we're seeing it as 1.3, which is the correct broadcast IP address on the /30 subnet mask. Also wanted to show you one last thing for this lab. We'll do show interfaces Gigi001, and then we can do a detail. And what the detail is going to allow us or give us is, if we just look at the difference, you see that the detail is really going to come in handy. All those extra options in troubleshooting and other ways, because we can see that just with the show interfaces, we don't have nearly as much information as when we do the show interfaces Gigi001 detail. Some of the options, just to name a few right off the top, we can look at quality of service options. We can look at the traffic stats. We can look at bytes and packets in and out. We can also look at a more detailed list of stats for flow input. You can see more error stats as well. And this is for the logical interface. So some of the main differences for the physical interface is we're seeing some of the quality of service options, which are not provided before. And for the logical interfaces is where we see a lot more options. Again, a lot of the reasons why you would use the detail statement is when you are troubleshooting specific problems. So I just wanted you to be aware of that command as well. So that concludes the introduction to Juniper Lab number 2, which in this lab we went over the basic configuration of physical and loopback interfaces. Specifically, we looked at Ethernet. We looked at the configuration of physical Ethernet interfaces. We went over how to admin down an interface and admin up an interface. We also showed you the importance of deactivating an interface. We showed you how to add a description to an interface. We also explained the concept of a unit and also a family. We performed show commands such as show interface description, show interface terse, and also show interface, then the interface name followed by detail. We added an IP address to the interfaces, to the physical and loopback interfaces. We also showed you how to add multiple IP addresses on a logical unit. We also showed you how to rename, showed you how to use the rename function to change the subnet from a /24 to a /30. So thanks for watching, and I hope to see you in the next video.